All right, folks, this is going to be all about using our calculator because we can do a lot of different things with our calculator that we haven't really talked about yet. But I want to talk to you about it because it's going to help you in checking your answers to things as well as on the calculator portion of the test. So there's really only two concepts that I need to go over with you guys right now in the calculator. And one that is evaluating a derivative without actually finding the derivative, and two, that is kind of using the graph to help us see what is going on with the derivative. So here with this question, right, this is the only thing that I'm going to do, and it should help you well enough, is I am given this function, 2 to the 2x of times cosine of x. So we can do that derivative, right? We'd have to use the chain rule and the product rule, and then I could plug in 3 and then keep going from there. But I can also do it in my calculator. So 2 to the 2x cosine of x. So if I go to my graphing calculator, 2 raised to the 2x cosine of x. And I have a trig function, so I'm going to want to make sure that my mode is in radians. Right there on this calculator is where I will check that I am in radians. I see I'm in radians, so I am good to go. Get out of here, music. You don't want to see that. All right, so I'm done with you. And if I look at the graph of this thing, well, that looks crazy. Wow, that's, oh my goodness, what goes on out there? That's wild. Absolutely nuts, right? But that doesn't really concern me out there. So something that your calculator has is it has a derivative function. So if you go to math, you have a nderiv, this number 8 right there. That numeric derivative is saying the derivative of the expression of the variable at a value, and then don't worry about that last part. So d over dx, and I want to do it of y1, because that's where I put it, right? I put it in y1, so when I go back home, what I can do is notice right here in green, and on your calculator that you have, it will just be option F4. That's why it's in that green, because it's the same N on my calculator that I have at least. It's this option F4. F4 right there, right above trace. All right, so when I choose that option on these calculators, it brings up something like that. Right, and I can choose my variables, and all that is doing is it is choosing your equation. So if I choose my y variable, I want to choose that equation. I want to evaluate it when x was equal to 3. Well, that is negative 96.8666. So negative 96.8 and then the devil's number. Negative 96.8. So f prime of 3 is negative 96.8 followed by the devil's number. And let's make sure I didn't have to round that. Nope, I didn't. That is how I would leave my answer right there. The AP test is going to go to 3 decimal spots. So if you are going to go to 3 decimal spots, 867. Thing is if you round this one wrong for some reason, then you lose your point. Stupid, huh? Right? So that's why Mr. Osborne and I like to tell you guys to go to 4 decimal places. So that way you don't have to worry about that last one. Even if you round it a little bit off, you're still going to get the credit because this one will be okay. Alrighty. So now, find the x values that f of x has a horizontal tangent. So horizontal tangent tells me I need to know when f prime is equal to 0. So there may be more for this graph. This may have a lot of horizontal tangents, especially as it goes outward forever. But what I'm going to do is just show you one of them. And the way I'm going to do it is I want to actually graph the derivative. So just like I used that derivative function, and above F2, at F2, so alpha window on this calculator, right, you'll come up with a screen that goes crazy. That nderiv is our option there as well. So we could have also gone to function, and that is a shortcut to get to your derivative. So I will still do d of dx, because I incorporating in terms of x. And you can type the function again if you want to, but you can also use that handy dandy y variable and do it at x equals x, so it does it for all x values. So now when I graph it, I have my derivative on there as well. So you could use the zero function in your calculator. Wow, this thing is just wild, man. I cannot control it at all. Right, and I can kind of see how my derivative is interacting. So it looks like, right, it's 0 right there. So what is that? 0.9459. And then I would also have another one way out there. So at 4.0875, right? And I would list those as the x values. And again, this wasn't the best example. I probably should have edited my example because there's going to be a lot of places, and there's really infinitely many places as I go outward that my derivative is crossing 0, right? That y prime is equal to 0. Something else that's kind of cool is if I wanted to figure out where the derivative is equal to the function itself, that would be when x equals 0.3686 there, right? So that means the slope is equal to the y value of my original function. So that's kind of a cool thing to note as well. But yeah, the red is our derivative, the green is our original function, and when you go to your y equals, right, you can see the green is your original function, right? That's the color of the graph right there. The red is my derivative, and this graphs the derivative based on this function. So if I change that function up there, this is the nice thing, right? If I change it to 2x, then I have a linear function, and the y2 bases how it graphs your derivative based on what y1 is. So it'll change everything about my graph. I have a linear function where the derivative is 2. So the only thing that we really can't do in the calculator is we can't say what the derivative is algebraically. So like I couldn't say that the derivative of e to the x is e to the x. You can verify with the numbers, and you can verify if you have to evaluate the derivative. So that's what the calculator is good for, and that's why we haven't talked about it a whole ton, is you still need to be able to evaluate the derivative by hand. But it is very useful in evaluating if I don't have to find it. Oh wow, I wrote that totally wrong. It's not f prime of 0. It's when f prime of x equals 0. Wow, holy cow. How did I do that? Why did I do that? So the x values that it has a horizontal tangent is when f prime is 0. I'm sorry, when the slopes are 0, right? The outputs of the derivative are the slopes. Man, Mr. Osborne said I was smoking crack. I must be. All right, what else did I want to talk about? I thought of something and then I noticed that was wrong. Oh, something else that I have used it for. So say I have the function of x squared minus 3x plus 2, and I want to find the tangent line at x equals 3. Right, so I could do y prime is 2x minus 3, so then y prime of 3 is 6 minus 3, so that slope is 3. Y of 3 is 9 minus 9 plus 2, so y of 3 is 2. What just happened? I don't know. That was crazy. All right. Okay, so then I would have my equation on my line would be y minus 2 equals 3 times x minus 3. To get the equation of the line in y-intercept, I could add the 2. So what I could do, x squared minus 3x plus 2, x squared minus 3x plus 2, and then I want to graph my line 3 times x minus 3 plus 2. 3 times x minus 3 plus 2. And I want to see if it's tangent at x equals 3. And it looks like I am intercepting x equals 3. You're not telling me it's an intersection. But it looks like it's pretty good, right? I mean, it's touching that right at 3. And I would say that that is a tangent line if I've ever seen a tangent line before. So it kind of helps you verify that you're on the graph, you're at the right position. But it just takes time, and then you guys don't always have the calculator on your test. Obviously, I don't know if you're using calculator or not, so I'm not going to split up this upcoming test in calculator and non-calculator portions. But on the AP test, if you have to take it in person, it is going to be about, 70% no calculator. So you guys need to be able to do these things without a calculator too, but obviously some of the tricks that we talked about, you have to use a calculator for. And that's where your calculator will help you with the speed of this stuff. And sometimes you just can't evaluate it without a calculator. Like if I was talking about the derivative of x to the x to the x, I don't even know how to take that derivative right now. I think we would have to do something called natural log. I can't remember what it's called, but it would involve something in rewriting this. But if all I'm trying to do is find y prime of 3, then I could type that first equation into my y1 and then find the derivative of it, evaluate it at 3, and your calculator will do all of the work for you. So you say, I ain't doing nothing, man. Other than that, hopefully this was helpful. Please, please, please let me know if you guys have any questions, and I will talk to you all soon. Bye-bye.